On this channel, we provide useful programming information with practical code examples. This time, we'll discuss service workers in TypeScript. We will explain service workers in TypeScript, including practical examples. Enabling subtitles will make the code descriptions easier to understand. A service worker is a request proxy that sits between the browser and the network. It enables fetch interception, cache control, offline support, and background processing, sync and push. Using TypeScript provides type safety and increases maintainability. Let's look at an example of enabling the web worker type in tsconfig.json. By adding web worker to the lib array, you can use types like service worker global scope, DOM, and web worker have different types, so it is common practice to separate the tsconfig.json settings for the browser, main app, and service worker. Service worker files are ultimately output to a path that matches the scope, usually the site root/sw.js. For security reasons, service workers only run over HTTPS, or on localhost. First, let's look at an example of registering a service worker from the browser main script. This process registers a service worker. Scope refers to the range of paths that the service worker can control. For example, if you place /sw.js directly under the root and set the scope to the root directory, you can control all the resources of the entire site. On the other hand, if you specify a particular directory such as app, only the contents under that directory will be controlled. Waiting indicates the state in which a new service worker has been installed and is waiting to be activated. At this stage, existing pages are still controlled by the old service worker, so it is common to prompt the user for confirmation, and after getting approval, call skip waiting to immediately activate the new service worker. This allows you to reflect the latest processes without waiting for the next page reload. Update found is triggered when the installation of a new service worker has started. When this event occurs, a new worker is set in registration. Installing, so by monitoring its state change, you can detect when the installation has been completed, installed. Furthermore, if navigator, service worker, controller exists, it means that an old service worker is already controlling the page. So this is an opportunity to notify the user about the existence of a new version. The controller change event fires at the moment when the new service worker starts controlling the current page. Reloading at this point will immediately apply new cache strategies and processing. However, automatic reloading can degrade user experience, so it is preferable to reload after obtaining user consent. By having the service worker receive a post message, type skip_waiting from the client and then calling self skip waiting, you can prompt an update. Next, let's look at a typical service worker example that implements app shell caching. When using service workers in TypeScript, it's useful to assign the correct type to self. In TypeScript, self is treated as any by default, so without additional typing, you won't get type completion or type checking for service worker specific APIs like skip waiting or clients. Specifying service worker global scope enables auto-completion, prevents misuse, and allows for safer development separated from regular DOM scripts. It demonstrates simple cache version management, pre-caching on install, deleting old caches on activate, and cache strategies on fetch, cache first for static assets, network first for APIs. During the install event, the app's static resources, app shell, are pre-cached. By calling self skip waiting, the new service worker is activated immediately, making the latest cache available without waiting for the next access. In the activate event, old versions of caches are deleted, and the service worker is kept up to date. Furthermore, by calling self clients claim, the new service worker can control all clients without waiting for the page to be reloaded. In fetch, you can intercept requests and control the response. You can implement strategies such as cache first or network first, which are useful for offline support and performance. If skip_waiting is received, calling self skip waiting allows you to instantly activate the waiting service worker. As a result, the new version will be applied from the next request without the need to reload the page. Cache first checks the cache first and returns the response immediately if available. If not, it fetches from the network and caches the result. This is suited for static files. This code demonstrates a cache-first implementation. If there is a cache, it returns it; if not, it fetches from the network and saves it to the cache. It's suitable for static resources that rarely change, such as images or CSS. Network first tries the network first and falls back to the cache upon failure. This is suitable for APIs where freshness is important. This code demonstrates a network-first implementation. If a network response is received, it saves it in the cache. If it fails, it returns the cached version. It's suitable for resources that require fresh data, like news articles or API responses. Stale while revalidate returns the cache first and simultaneously updates it from the network in the background. This balances response speed and freshness. This code returns the cache immediately if available, while fetching new data from the network in the background to update the cache. It provides fast responses to users and uses updated content for the next access, making it suitable for UI or lightweight data delivery. In this way, you can compile SW/TS using the TSC command. If no errors occur, you can confirm that the settings and type definitions are functioning correctly. Service Worker updates are not immediate. The new version will remain waiting until existing tabs are closed. Here, we implement a system to notify the client when the new version is ready and reload the page safely based on user action. In this code, notify clients updated is called at the end of the activate event to notify all connected clients that the new version is ready. Clients claim is a method that immediately brings currently open pages, clients, under the control of the newly activated service worker. Normally, a service worker starts controlling the page only on the next load, but by using clients claim, you can bring the page under control immediately without reloading. The client receives SW updated via the message event and displays an update notification in the UI. When the user chooses to reload, window location reload is executed, updating old HTML, CSS, and other resources on the page to the latest version. This ensures that the cache and control by the service worker, switched with clients claim, are reflected throughout the entire page. Prepare /offline.html for critical navigation, and provide a minimal UI that conveys meaning even without images or fonts. If an API call fails, show the last cached state if possible and try to refetch in the background to improve UX. Precache /offline.html during the install event so you can return at least a minimal page when the network is unavailable. In the fetch event, you can monitor navigation requests with request mode == navigate and specifically target page transitions. Fallback to /offline.html when the network fails, ensuring it displays even when offline. Next, let's look at an example of typed messaging between the client and the service worker. Because the service worker operates independently of the page lifecycle, bidirectional messaging is important for notifying states and executing commands. Specifying types for messages helps prevent incorrect message sending, enables code completion, and makes your implementation more robust. Definition of message types. SW to client is the type of message sent from the service worker to the client. Client to SW is the type of message sent from the client to the service worker. This allows you to clarify the types of events that can be exchanged through bidirectional communication. Processing on the service worker side. The service worker receives messages from the client and branches processing based on type. For clear_cache, it deletes the cache and then notifies all clients with cache cleared. For ping, it replies to the original client with a ping message including a timestamp. Notify all clients from service worker. Use clients. Match all to get all window tabs. By sending post message to each, you can broadcast messages. This can be used for update notifications, such as SW updated and error notifications. Processing on the client side. By sending a ping from the client and receiving a response from the service worker, you can verify that bidirectional communication is working properly. This makes it easier to test connection states and message handling. Using typed messages makes which messages can be sent and received clear, and auto-completion and type checking improve safety. Post message enables one-to-one communication and broadcast enables one-to-many communication. You can easily implement essential features like update notifications, SW updated, cache management, cache cleared, and health checks, ping. Using TypeScript adds type safety to service worker API calls and messaging, greatly improving development efficiency and maintainability. Understanding the install, activate, and fetch lifecycle events, and choosing the right caching strategy, such as cache first or network first, for each situation leads to a better user experience. For operations, understanding cache version management and update flows, update found, waiting, skip_waiting, etc., is essential. By adopting typed messaging for client, service worker, communication, you can prevent misimplementation and establish a system that is easy to extend and maintain in the long term. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. Thank you for watching. Subscribe to the channel and check out our new videos.